Good morning. Again, good morning to all of you. Our lesson for today is we're going to illustrate a quadratic equation. Okay, so we learned from the past that a quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Okay. Ax squared, we call this the quadratic term. Bx is the linear term. And c is the constant term. Okay, example of a quadratic equation in the form of ax squared plus bx plus c equals 0. 2x squared plus 5x minus 3 is equal to 0. This is a quadratic equation in standard form. So a is equal to 2, b is equal to 5, and c is equal to negative 3. Okay, another example. 3x squared minus 4x plus 5 equals 0. A is equal to 3, b is equal to negative 4, and c is equal to positive 5. Okay, another example is you have 3x times x minus 2 equals 10. Now, this is an example of a quadratic equation. However, if you're going to look at this equation, it is not written in standard form. So what are we going to do? So we're going to expand the equation and make the equation equal to 0. So first, we have to expand. First, we're going to multiply 3x times x. So we have 3x squared. 3x times negative 2 is negative 6x equals 10. Okay, now how are we going to make this in standard form? So we're going to subtract 10 from both sides. We have 3x squared minus 6x minus 10 is equal to 10 minus 10. Okay, so 3x squared minus 6x minus 10 is equal to 0. Okay, so the equation becomes a standard form of a quadratic equation. Now we can identify the value of a, which is equal to 3, the value of b, which is negative 6, and the value of c, which is equal to negative 10. Okay, here is another example. We have 2x plus 5 times x minus 1 equals negative 6. Okay. So if you're going to look at the first side of the equation, we have two binomials. Okay, using the FOIL method, we're going to expand the given equation by multiplying 2x times x. So this will give us 2x squared. Then we have the outer term, 2x times negative 1, we have minus 2x. The inner term, plus 5x, and 5 times negative 1 will give us negative 5 equals negative 6. Observe that we have similar terms. We're going to add that. So you have 2x squared plus 3x minus 5 equals negative 6. You notice that the two similar terms here, they have different signs. Now, because we're going to add them, you're going to apply addition of integers. Okay. So because they have different signs, we're going to subtract and affix the sign of the greater absolute value, which is positive because 5 is greater than negative 2. Okay. And then we're going to make this equal to 0. So we have 2x squared plus 3x minus 5. We have negative 6. We have to eliminate this so that this will be equal to 0. So we're going to add 6 from both sides. So we have negative 6 plus 6. So the equation becomes 2x squared plus 3x plus 1 equals 0. Okay, it is already in a standard form. So A is equal to 2, B is equal to 3, and C is equal to 1. Okay, let's try this. Write in a standard form and determine the value of A, B, and C. So number 1, you have x squared is equal to 7x. Okay, so this is x squared minus 7x equals 7x minus 7x. So x squared minus 7x is equal to 0. So A is equal to 1, B is equal to negative 7, and C is equal to 0. Okay. What about number 2? Number 2, you have 5x squared is equal to negative 4. So we have 5x squared plus 4 is equal to negative 4 plus 4. So we have 5x squared plus 4 is equal to 0. So you have A is equal to 5 and B is equal to 0 and C is equal to 4. What about number 3? So in number 3, again, you're going to expand. So you have x plus 3 times x plus 4 is equal to 0. For number 3, we're going to expand x plus 3 times x plus 4 equals 0. Again, using the FOIL method, we have x times x, x squared, x times 4, we have 4x, 3 times x, we have 3x, and 3 times 4 equals 12. This is equal to 0. We have x squared plus, similar terms, 7x plus 12 equals 0. So A is equal to 1, B is equal to 7, and C is equal to 12. Okay?